So we want to turn tons per yard cubed into grams per centimeter cubed. Both of these are kind of density units, but we want them in more standardized density units. So I've got 2.34 tons, and then I've got yards cubed. You guys have a tons conversion? Sorry. 2,000. So why did I write it in that orientation? So I can get rid of the tons. So now this tons thing disappears. So now I've got pounds over yards cubed. What should we do next? We don't want pounds, right? So we'll put pounds in here. We can turn that into kilograms. So one of these and 2.2 of these. And then I can get rid of the pounds unit. And then I can go 1 kilogram is 1,000 grams. And so then my kilograms are gone and I've got grams. So half of my problem's taken care of. I need to get the other unit into the format that I wanted. So now I've got yards cubed and I need to get that into centimeters cubed. So we will, I need to put the yards cubed in the numerator so I can cancel it out with that yards cubed all the way at the front in the denominator. So I'll put 1 yard. I don't know, it doesn't really matter how we do this, but I don't have a lot of space left, so whatever. 3 feet. The problem with that is if that's cubed, I'm going to need to cube that. I'm going to need to cube that. I'm going to need to cube that, right? So there's 3 yard units right here, correct? This is really yards times yards times yards. That's what this means. So if I just wrote yards in the numerator, I would only cancel one of those 3 out. So then that would make me do 3 little fractions to get rid of them. Or I could say 1 yard is 3 feet and then cube everybody inside of there. It works out to be the same thing. So when I do that, then I can get my yards cubed to cancel out. And now I have this feet cubed, which I don't want either. So I'll put feet cubed up here, 1 foot here, and I can put 12 inches and then inches. So everybody here gets cubed. And then doing that, I get my feet to cancel out, my feet cubed to cancel out. Now I've got inches cubed. And then I can do 1 more. So if it's 1 inch is 2.54 centimeters, then I can cube all of these guys. And then all of my units are gone, except for the unit that I want, which would be, no, not that, don't want to do that. Oh, that's weird. All right, well, that doesn't work out for me. Except for that centimeters cubed and that grams. So my railroad track is set up correctly. I just need to do the math to calculate out what it ends up being. So we're going to take 2.34 times 2,000 times 1,000 times nothing divided by 2.2 divided by 3 cubed divided by 12 cubed divided by 2.54 cubed. And I get 2.78237 grams per centimeter cubed. My answer can be how many numbers? Just 3, because I have 3 sig figs with this right here. So then my answer is going to be 2.78 grams per centimeter cubed. Okay, so we want to rearrange this guy to solve for temperature final, so the 9 goes up on the other side, the 5 goes down on the other side, so we end up with temperature times 9 divided by 5, and that equals temperature final minus 32, so I'll add 32 to both sides. So I end up with temperature final is equal to temperature Celsius times 9 divided by 5 plus 32. Okay. Why should you not be super excited about this? Because you're in Canada, they're the metric system, so it's kilometers per hour. So let's figure out what the kilometers per hour would actually work out to be in miles per hour. So if it says 125 kilometers per hour, so there is 1 kilometer and 1,000 meters. That cancels. And there are 1 meter and 100 centimeters, and that cancels. And there are 2.54 centimeters, and then there's 1 inch, and that cancels. And there are 12 inches and 1 foot, so the inches cancel. And there are 5,280 feet for 1 mile, so the feet cancel. And so the only units I have left are the hour that I started with and the mile that I just made. So we're looking at 125 times 100, or 1,000 times 100 divided by 2.54 divided by 12 and divided by 5,280. 77.7. And so since we had 3 sig figs here, I get 3 sig figs here, and then it'll be miles divided by hours. Okay, how about this next one? What's the density of the phone and the case have to be? Less than 1. So if I know that the phone and the case together have a total mass of 180 grams, so the case itself has to have a volume of what? Anything bigger than 180, right? If it was 180.1, it would float. If it was 180, it's not going to float, it's just going to flow with the water. So if for some reason a current takes it down, then it goes down. Can it come back up? Yep, if the water pushes it back up. But if it's a little bit bigger in volume than it is in mass, then the thing's going to float. So all you need is, your density needs to be greater than 1 gram per centimeter cubed. So then the only way to get that is if I know my mass is 180 grams, then this number right here needs to be, 180.1 milliliters. So my volume is got to be greater than 180 milliliters. There is a most likely perfectly preserved iPhone on the bottom of the Columbia someplace, because my case was not 180 milliliters or bigger. So it's just hanging out somewhere. So if somebody wants to go dredge that up. Battery, I'm sure, is dead because it was like 5 years ago, but I'm sure there's nothing wrong with the phone. What can you say about the magnitude of the charge on the proton relative to that of the electron? So the proton's charge is a +1, and the electron's charge is a -1. And so these two charges, what can you say about their size? Their size is equal. One's positively charged, one's negatively charged, but they exactly cancel each other out. All right, so formula: sulfate SO4 minus 2, sulfite SO3 minus 2, nitrate NO3 minus, nitrite NO2 minus, and ammonium NH4 plus. Okay. Questions?
So you know, like, okay, besides the ending of the sulfite sulfate thing, will we need to know the compositions of that as
I don't know what you mean.
Like if you said, okay, which one has more electrons, sulfite, sulfide? Like, is that the question? Or,
Not right now.
okay.
Before the third exam, you'll be able to do that. Okay.